Hello everyone. Today I am going to give a presentation on wheat leaf disease classification using modified ResNet50 convolutional neural network model. So I am studying in Sri Venkateswara College of Engineering in Department of Electronics and Communication Engineering. So the subject code is 18EC S84 and it is under the guidance of Dr. J.J., Head and Professor, Department of ENCE SVCE Bengaluru. So I will move on to the next slide. So these are the table of contents. One is introduction, history, methodology, block diagram, flow algorithm, applications, results, references. So first we will be discussing about the introduction. So, in introduction, as we all know, wheat is one of the most vital staple crops globally. So, as it is playing a very crucial role in food security, however, wheat cultivation is faces very significant challenge that poses by various diseases that can reduce the crop yield and quality. So early detection and accurate classification of these diseases are paramount for effective disease management and crop protection strategies. So in recent years, advancements in artificial intelligence, particularly deep learning techniques we are using for identification of wheat leaf diseases. So then in deep learning, especially here we are using CNN technique, that is convolutional neural techniques. There are many deep learning techniques, but here we are using CNN techniques. Next, the CNN has demonstrated the exceptional capabilities neural in image recognition task, making them uh, particularly suitable for disease classification in plant pathology. So, as we all know, agriculture stands as a vital cornerstone for sustaining life, particularly with the global population. As we all know there is more population in India and it stands first for more population. So the imperative to enhance both the quality and quantity of crops have become increasingly pressing. So wheat is one of the most important cereal crops globally, providing a significant portion of the world's food supply. Wheat plants are susceptible to various diseases that can significantly reduce the yield and quality. So, as I previously told about uh, wheat disease classifications and what are the techniques we are used to identify this classifications, wheat disease classifications, and what were the techniques that old people were using, and what are the techniques that new advanced AI techniques the people now are using. I'll move on to the next slide. So next we will be talking about the history. So here history is, first one is wheat leaf disease classification has evolved from manual methods to deep learning techniques. As we all know, a manual method is nothing but it refers to a process or a technique that is performed by hand or using simple tools without the assistance of automated or electronic device. So manual means here we are not using any electronic devices. Here the task will be performed either by hands or simple tools. So that is actually before classifying these wheat leaf diseases, manual methods were used. But after the technology has become advanced by using AI, so now they are using deep learning techniques. As we all know, deep learning is a one of the subset of a machine learning. So there are many deep learning techniques such as classic neural networks, convolutional neural networks, recurrent neural networks, restricted Boltzmann machine, transfer learning, generative adversarial networks, organizing maps, deep reinforcement learnings. So the next point is the adoption of CNN like ResNet has significantly improved disease detection accuracy. So as we all know, by using this ResNet50 CNN model, that is residual network. Residual network is nothing but it is a specific type of convolutional neural network that is introduced in 2015. So then it is commonly used to power computer vision applications. So here by using this ResNet50 model, the detection or the detection of wheat disease classification has become efficient and improved. So next is researchers have modified ResNet50 by fine-tuning and adding layers for enhanced feature extraction. As the statement states that the researchers who had researched about this topic, that is a wheat leaf disease classification using CNN model, they have used modified residual network 50 CNN model because the features and the layers which were in the ResNet 50 model is modified with some extra layers and fine tuning, and by adding an enhancement features for extractions. So here the researchers have been using the modified ResNet 50 model. So it includes advancements, dataset curation argument. So as we all know, deep learning, in deep learning here we are using CNN. So in CNN there are some steps to be followed for classification of wheat leaf diseases. The first one data set curation. The first and foremost step is that we need to find the data sets. The data sets may include like healthy wheat leaf data sets or the leaf which is affected by the diseases. So it will include both the types of leaf disease, wheat leaf diseases classifications. Whereas after data set collection, then we'll do the data augmentation. So in augmentation here we will collect the pre-processing features, and in data evaluation we will evaluate the features and classify into classify the wheat leaf into four diseases. So I'll move on to the next slide. So now we will be going to discuss about the methodology. So in methodology, what we can so this is the most important in wheat leaf disease classification using modified ResNet CN model. So next I'll move on to the slide. So fast, as I told in the previous slide, data set is the most important part, where wheat disease classification data sets, that is LWDCD 2020 compromise. So here we are inducing around 4,500 curated images divided into three devices groups and one normal class. As I told, the data set not only include the affected wheat leaves, it also includes the normal healthy wheat leaf. These images capture complex background varying disease stages and similarities across different illness. So how it will classify means we will pre-process the features. So features like such as capture complex backgrounds and disease stages. So some of the disease will be having first stage, second stage, and third stage, and the similarities. Okay, and the similarities across different illness. So how can we find whether the wheat leaf is affected by disease or not? While seeing the condition of the leaf, whether it has become rust or like that, we can detect the condition of the wheat leaf. So these are the some of the features that have been extracted to identify the disease classifications, for identifying the disease classifications. So the data sets include so what are the data sets we are collecting is, that is leaf rust, leaf rust, crown and root rot, but the healthy wheat, and then wheat loose smut. These are the some of the leaf diseases we are considering here, and these are the four main important, we are just focusing on this four diseases, which will be found at the last. So next, so this is the one of the wheat leaf diseases, that is wheat rust. As we can see here, that on the leaf of the wheat there is a thing called orange color. So this is nothing but a wheat rust. So next disease is, so here it is, this is a crown root rot. So as we see in the picture, this is a root. So this part is called as an root rot, and this is called as an crown. I'll move on to the next disease. As it is a healthy wheat leaf, here we can see there is no disease on the leaf, as it is looks like very healthy, and we cannot see anything, any type of what we can say, I mean any type of particles are not present in this leaf, as it is very clean. So it is a healthy wheat leaf. Next, I will move on to another leaf disease. So that is wheat loose smut. So this is the image of the wheat loose smut. So these are the four images we are introducing into the CNN model. So based on this, it will classify the wheat leaf diseases, like whether this is affected by this or that. So I will move on to the next slide. So that is so as we move on to the data imputation, as this is the next methodology here we are using. So here it is for a multi-domain image to image interpretation task, a collaborative generative adversarial network is utilized as an image imputation, such that generator and discriminator network may accurately estimate the missing data of the dataset using the residual clean dataset. So image with enhanced visual quality are produced using the collaborative general adversarial network. So what the job of this collaborative generative adversarial network is, it will provide a high visual quality of the images, so that are produced during this collaborative adversarial generative network. A generative method, it detects the fine scale functional structure across individuals in imaginary sets. So when distinguishing which components were seen and which were imputed, the discriminator is trained to minimize the classification loss. So while the generator is thought to increase the discriminator misclassification rate. As a result, we can state that the adversarial training approach is used to train these two networks. So the next step is we'll move on to the so this is being the next step, that is data augmentation. So it is to minimize the overlifting. Data augmentation is a common method for enhancing input data, feeding it to a convolutional neural network. It is carried out a data augmentation approach based on the integrity transformation concept. Then it is to minimize the spareness in each feature space. we set we start with a few existing data points and add noise and produce new data points. After that, we create a various image that correspond to the new data points. A small number of instances are used to build an image transformation tree, which then generates a new data. This helps us to minimize feature space and construct more robust data for classifiers. So, the modified ResNet50 consistently outperformed other models in terms of accuracy, precision, recall, and F1 scores. This demonstrates the robustness and the reliability of the model is classified with leaf disease accurately. So next we will move on to the next slide. So here we are using modified ResNet model. So that is to train the effective extractor, feature extractor. CNN is used to extract features from each leaf image. So as we all know, we have to extract a feature. So based on that feature, the CNN model will classify the wheat leaf diseases. The CNN network is pre-trained and is used for feature extraction and parameter initialization, and then network is retained with some samples like from the newly processed data. So deeper levels of ResNet 50 can predict the variance between the objective function. So and the output of the preceding layer. As a result, deep residual learning is an effective technique for training the network to anticipate uh, from the previous layer. So next is that the approach uses wheat leaf images to generate a feature vector. So to extract the deep features, so the proposed approach for effective production of wheat level disease relies on the transfer of learning and fine tuning deep pre-trained CNN model. So here we will train the model before itself. So it can extract the features what are the leaf. First we will introduce these images into the CNN model. So the CNN model first will pre-process the images, like it will classify the images according to the features which it has extracted, and it gives the final output as in the four classifications that it gives, whether it is an healthy wheat or it is an root rot, like that. So next we will move on to the next slide. So this is the block diagram. Okay, here we'll be discussing about the what are the steps will be included in the CNN model. So first is dataset. As I told, dataset is very important. First we need to collect the datasets. So the dataset may include many images. It's not only these types of wheat leaf diseases. It contains all types of wheat leaf diseases not only crown root rot, leaf rot, wheat loose smut. It contains all types of wheat leaf diseases. So here we will introduce a 4500 of images in our project. So then the next step will be going on is pre-processing data imputation. As I told, here you will be using generative network to extract the features, as it is very good at extracting. Then the next is classifying, whether it is an inception v3, densenet, resnet, modified resnet. So here we are using modified resnet. Then it will classify into four wheat leaf diseases. So first four sections, that is wheat, healthy wheat. So it will give the result as in first is healthy wheat. So this much amount of images are healthy wheat, and this much amount of images are crown root rot, and this much amount of images are leaf rust, and this much amount of leaves are wheat loose smut. So these are the different output we'll be getting after inducing this 4500 images, which consist all types of weed leaf diseases. So next I will move on to the next slide, that is so next is flow algorithm. So in flow algorithm, it shows the steps exactly what it's going on. So the first step is collection of data, as I told. So first we need to collect a diverse data set of the wheat leaf images that contains different disease classes. Okay. So as I told, it not only contains that four diseases, it will contain all types of disease classes. So the next step is data pre-processing. First, after collection of data, we will pre-process the data. So we have to resize all images to a uniform size suitable for input to the CNN model. So after collecting the images, we have to resize the images. So that should be suitable to that should be suitable for input into the CNN model. So we have to adjustment in the pixels, standardize range, and then we have to augment the data set using techniques such as rotation, flipping, and cropping to increase the variability and improve model the generation. So next step is data processing. So model preparation. So here load the pre-trained ResNet CNN model. So here we are using modified ResNet CNN model. So here we are not only using only CNN model. Here we are using a modified ResNet CNN model. So with weights initialized from pre-trained model. So here we have to train the model. So a large by a large scale data set. Next is model modification. Here we'll modify the ResNet50 architecture to adapt it for wheat leaf disease classification. Adjusting the number of layers and filter sizes are necessary. So we will adjust the number of layers. As I told, there is an difference between only ResNet50 CNN model and modified ResNet50 CNN model. So here in modified there will be an extra additional layers which can extract the specific features. So here in model modification we will do this. So the next will be transfer learning. So in transfer learning, freeze the weights of early layers in the network to retain learned features while fine-tuning the later layers for the wheat leaf disease classification task. So the next is model training. So we have to train the model so as it has to classify the uh, data set which contains all types of disease classes of wheat leaf images. So it has to classify. So for that we have to train the model. So train the modified ResNet50 CNN model using the training set. So that is optimizing the model parameters based on chosen loss functions. So next is we have to monitor and iteration. So we have to monitor after training the model, then we will evaluate the model. Here evaluating the trained model performance on the test set using standardized classification matrices. Here we will be using evaluating by classifying the matrices, analyzing the confusion matrix to understand the model classification performance across the different disease classes. So the next is the next is we'll move on to the monitoring and iteration. So in monitoring and iteration, we have to monitor the performance of the that is modified ResNet CNN model. So as it will be deployed model in real world application and collect the feedback from the users. So this is the flow algorithm for this project. So the next we will be discussing about the applications. So I will move on to the next slide. So as I told, the first application will be a precision agriculture. So in precision agriculture, what we will do means the primary application lies in precision agriculture, where the CNN model can be deployed as a part of smart farming system to enable early detection. As I previously told, before the wheat leaf disease classification, the farmers were using manual methods. The manual methods are nothing but by using ants or some tools, but this is the very effective method for early detection of wheat leaf. So after we get to know this is an early detection, we can target the treatment of wheat leaf diseases. So next is crop monitoring and management. So in crop monitoring and management, the CNN model can be integrated into agricultural drones or remote sensing platforms to perform automated crop monitoring over large agricultural areas. As we all know, the agricultural area will be wide, so we cannot in person go and walk um, through all the place in the agricultural land. So instead of walking, we can check through a drone or remote sensing platforms. So this is nothing but a crop monitoring and management. So next is early warning system. As we are using here, it is a modified CNN model. So here we'll be having some early warning systems for wheat leaf diseases. Helps primitively. It will alert the farmers to potential disease outbreaks or epidemics. So next is crop insurance and risk assessment. So here, insurance companies and risk assessors can utilize the CNN model disease classification capabilities to assess the risk of crop loss due to the wheat leaf diseases. So as I told, insurance company and the risk assessors will use this model to prevent the risk of crop loss. So the next slide is result. So here the last part will be the result. I'll move on to the next slide. So the result includes here after the input data are pre-processed through this updated network to generate a features for each image of the data set, after which the network classifier classifies the classes. A healthy wheat leaf and 3 disease classifiers were classified using the suggested methodology. So the result is, after inducing this data set into the pre-processed trained model, that is CNN model, it will classify into these classes such as like healthy wheat leaf and 3 disease classes, uh, as I told before. So the efficiency, as coming to the efficiency, this model is very efficient as it can give warning systems, and it is a the results of the so these are the some of the results of the early detection, and so these are the some of the results of the experiments. So the data is here, the data will be randomly partitioned. So that will be into 20% testing and 80% will be training. So using the CNN architecture and a proposed tuning technique. So the new convolutional layer used a filter of size which when the proposed model was applied to the data set. So next I'll move on to the next slide. So this is one of the confusion matrix where we can understand easily. So these are the four, this is confusion matrix of ResNet50 model. So this is 50 model, and this is for DenseNet, and this is for Inception v3. So this involve a true positive, false negative, and true negative. So next we will move on to the next slide. So reference. So these are the some of the references which I referred. So the first is LinZ, a unified matrix-based convolutional neural network for fine-grained image classification of wheat leaf diseases. So next is Noon SK, use of deep learning techniques for identification of plant leaf stresses. Next is Shrestha G, plant disease detection using CNN. So the next is Panigrahi, that is maize leaf disease detection and classification using machine learning algorithms. So next is Jiangzi, recognition of rice leaf diseases and wheat leaf diseases based on multitask deep learning techniques. Next is W, identification of wheat leaf diseases and their severity based on elliptical maximum margin creation, metric learning. So thank you for watching my video. Please subscribe, share and like the button. And I hope it was useful.